Have you ever looked up at the vast blue sky and just wondered, why blue? Or maybe you've been mesmerized by a fiery red sunset and thought, what's the magic behind that? Sunlight is actually a mix of all the colors of the rainbow, just like you see when you shine light through a prism. Each color travels as a wave, and they all have different wavelengths. Red has the longest wavelength, while blue and violet have the shortest. During the middle of the day, the sun is high overhead. Its light takes the most direct, shortest path through the atmosphere to reach our eyes. When sunlight hits the air, it meets tiny molecules of nitrogen and oxygen. These particles are far smaller than the wavelength of visible light. And that's where something called Rayleigh scattering begins. This happens when light interacts with particles that are much smaller than its wavelength, such as the molecules of nitrogen and oxygen in our atmosphere. When we say light is scattered, it means light waves are deflected in many directions instead of continuing straight. When light hits a molecule, its electrons vibrate and re-emit light in new directions. The light is then redistributed and spread out. Since blue light has a shorter wavelength than red light, it scatters more widely in all directions, bouncing around the atmosphere. This scattered blue light reaches us from every part of the sky. The scattering tension is inversely proportional to the power of wavelength. So the shorter the wavelength, the more it gets bounced around by tiny air molecules. While red light barely feels the tiny air molecules due to its longer wavelength, so it hardly scatters at all. It just keeps traveling straight through the atmosphere, in the same direction the sunlight was heading. Violet light actually scatters even more, but our eyes are less sensitive to violet, and much of it is absorbed by the upper atmosphere. As the day comes to an end, the sun drops lower in the sky, nearing the horizon. Its light has to pass through more of the Earth's atmosphere to reach us, similar to taking a scenic route rather than a direct highway. During this longer journey, most of the short wavelength blue and violet light gets scattered away before it can reach our eyes. The remaining longer wavelengths, like reds, oranges, and yellows, penetrate the thick atmosphere more directly without getting scattered as much. By the time the sunlight reaches our eyes during a sunset, it's mostly composed of these warm, fiery colors. So, the next time you're enjoying a bright, sunny day or watching a stunning sunset, you'll know exactly what's happening.